the fact that he's talking about going to 1 million GPUs, we don't know for sure that he thinks that we can network 1 million GPUs together as one single giant supercomputer brain. If we can do that, that implies a level of progress that is insane.
First, Elon is amazing. And you pointed this out because you heard something from the All In podcast, which we'll play and we'll listen to what they said. But you said, wow, if I'm hearing this correctly, Elon personally solved the flaw in his cluster design that allowed xAI to scale Colossus to 100,000 hoppers. That's 3 times the size of the next largest cluster. They're about to add another 100,000, followed by Blackwell. Ultimately, Elon, yes, this news came out recently that Elon wants to scale up xAI, that supercomputer in xAI, to be 1 million GPUs. We saw the Memphis City Council saying that they need to approve that. No wonder Genesis has given a priority on Blackwell. If xAI can get to 1 million GPU clusters, that's a 30 times size increase over the previous largest cluster. That's not double, that's 30 times. And then once it's achieved, it becomes the new benchmark that the other Mag 7 and the FANGs and the sovereigns have to compete against. That's why Jensen gives them priority. Gets at least another order of magnitude step up in sales volume. Mind melting. Before we play the video, give us an update of why you said this.
Yeah, I mean, the biggest epiphany for me, well, I guess there were two. One of them was I didn't fully appreciate the fact that Colossus, when they announced it, and the fact that it was reaching this 100,000 GPUs, that I didn't think that was all networked together as a single unit. I kind of just, for whatever reason, assumed that it was like these other 30,000 clusters and we just had multiple of them that were running kind of side by side in parallel. So I thought that was like the total size of GPUs that they had. And the distinction between having 100,000 GPUs networked together as one single brain, one single GPU, as Jensen likes to say, that is a fundamentally different thing than 3 GPU clusters that are 30,000 or 33,000 GPUs each. And it allows for breakthroughs. And this is, one of the things that we'll get into at the All-In clip, that we get to test new frontiers of what an LLM can do, because we haven't had like this wall that this is the wall that every other company has come up against, that if you can only do 25, 30, 32, 33,000 H100s as a single cluster, and everyone has that same technical limit, then the size of the problem that you can solve with those GPUs is the same. There are some optimizations that you can do around that allow you to try to, maybe get a little bit more performance than your competitor. But, it's kind of like in Formula One, where there are a lot of rules that govern what you can and can't do with your car. And by doing that, they really are able to level the playing field. And at the end of the day, the races end up being all about really how good the drivers are, because everyone's essentially, driving the same car. Maybe there's some minor tweaks and some minor differences. Maybe that gives you a little bit of a competitive edge, but it's not like a runaway victory. And so being able to go from 30,000 GPUs networked together as a single brain to 100,000 means that now it's like an F1 race where one of the cars is just 3 times more powerful than any of the other cars. And obviously in that scenario, it's going to be a runaway winner, because that driver just has, like, he could be a terrible driver and still blow away the competition because he just has a lot more to work with.
Okay. Thank you for explaining that. That's a big deal. Let's listen to the All In podcast, because that's where this came from. And they dropped this episode, and then these guys were talking. Who's Gavin Baker and JT Lonsdale? We're going to listen to Gavin Baker.
Yeah, so they're both venture capitalists. JT Lonsdale is one of the co-founders of Palantir. I really wasn't familiar with Gavin Baker. I think he actually is a relatively prominent person inside Silicon Valley, but wasn't someone that I was personally familiar with beforehand. But his level of understanding of this specific problem is excellent, and he's also one of the investors in XAI, and so he's got whatever
he knows
access to information that the people on the XAI cap table have, and that gives him some extra insight. But everything that he's talking about here in this clip is based on the publicly available statements. So he's not really providing material, non-public information. He's just helping us to understand the information that's already out there publicly better.
Sounds good. All right, we're going to play this. It's a 6-minute clip. Let's watch some parts of it.
Cal, do you want to talk about AI with Gavin and
Yeah, I think
XAI?
that would be like a great next place to go. Would be to talk about the supercomputer being built by a friend of the pod, Elon. He's now got the world's largest supercomputer, and he's going to 10x it, according to reports.
Yeah, and I would just say this is, I think, a very important moment for AI, for this entire AI trade in public and private markets. Everybody, I'm sure, who watches your podcast is very aware of scaling laws. And we have not had scaling laws for training, or if you 10x the amount of compute used to train a model, you significantly improve the intelligence and capability of that model. And often there are these, kind of emergent properties that emerge alongside that higher IQ. No one thought it was possible to make more than 25,000, maybe 30,000, 32,000, pick a number, NVIDIA hoppers coherent.
So for those who don't know what the scaling law is, it basically says that, if we train with 5,000 GPUs on this same data set, and then we do our next model, and this time we use 10,000 GPUs on it, that using more GPUs gives us a better model on the backside. And this is what we saw with, from GPT-1 to GPT-2 to GPT-3 to GPT 3.5 to GPT-4. Each one of those steps that we saw from OpenAI, they added more GPUs to the training every time they went to the next model. And so growing the number of GPUs that were being used to train, they're also growing everything else. They're growing the data being used to train and all this other stuff. That those always produced better final models. That, O1 is a smarter, better model than anything that came before it. But we kind of reached this plateau where O1 is not trained with any more GPUs than GPT-4o. And this is one of the things that people are saying, we're having a hard time now getting better performance out of ChatGPT. And the reason is they haven't been able to scale these GPUs because they hit they hit this ceiling, this limit, this wall. So now what OpenAI is doing through ChatGPT is they're having to think for longer in order to pretend that we were able to train with more GPUs to begin with. Yeah, and so now they're shifting more of the computational workload to inference time instead of having it done at training time. And this is kind of a way to try and get around this scaling law to make advancements without having more training compute to begin with. And so anyways, that's the setup for what a scaling law is, so that people can understand specifically what he's talking about as we launch into this next topic.
Thank you.
Cluster that each GPU, to kind of simplify it, knows what every other GPU is thinking. So every GPU in that 30,000 cluster knows what the other 29,999 are thinking. And you need a lot of networking to make that happen.
Enabled by InfiniBand, right?
InfiniBand, and I think even more importantly, NVLink. Although a lot of Ethernet is, never bet against the internet, never bet against Ethernet. Like if you read the Llama 3.1 technical paper, got a lot of people excited about skinny link Ethernet. But
just to slow down for the audience here, Gavin, maybe explain why transporting information between the GPUs is important. And we're in the weeds here a little bit. Everybody's heard of Ethernet, but some of the other protocols and ways of moving stuff around, large amounts of data. That's what these H200s, H100s do particularly well. They'll move a couple of terabytes a second from one processor to the next processor.
Yeah. So, picture a server In the case of a GPU, it looks like maybe 3 pizza boxes stacked on top of each other, and it has 8 GPUs together. And those 8 GPUs are connected today with something called NVLink. Broadly, you can think of the speed of communication. On chip is the fastest. Chip to memory, next fastest. Chip to chip within a server, next fastest. And so you take those units of servers, which are connected, the GPUs are connected on the server with a technology called NVSwitch, and you stitch them together with either InfiniBand or Ethernet into a giant cluster. And each GPU has to be connected to every other GPU and know what they're thinking. They need to be coherent. They need to kind of share memory. For the compute to work, the GPUs need to work together for AI. And no one thought it was possible to connect more than 30,000 of these with today's technology. From public reports, Elon, as he so often does, focused deeply on this, thought about it from first principles, how long it should take, the way it should be done. And he came up with a very, very different way of designing a data center. And he was able to make over 100,000 GPUs coherent. No one thought it was possible. If I was a last minute ad for this, but I would have said there were all these articles that were being published in the summer saying that no one believed he was going to be able to do it. It was hype. It was, ridiculousness. And that was coming. The reason the reporters felt comfortable writing those silly stories is because engineers at Meta and Google and other firms were saying, we can't do it. There's no way he can do it. He did it. And I think the world really only believed it when, Jensen did that podcast, I think with, wasn't it with Gerstner?
It might have been with Gerstner.
Yeah, I think it was with Gerstner, and said what Elon did was superhuman. No one else could have done it. And I actually think you can argue that Elon doing that in a lot of ways kind of saved Nvidia from a tough 6-month period when Blackwell was delayed, because everyone who was waiting for Blackwell and thought it was impossible to make 100,000 hoppers coherent rushed out and bought a lot of hoppers to try and do it themselves. Now we will see if someone else is able to do it. It was really, really hard. No one else thought it was possible. And as a result of that, Grok 3 is in trading now on this giant Colossus supercomputer, the biggest in the world, 100,000 GPUs.
In Memphis. At the old Electrolux factory, and they're putting a lot of energy in there, a lot of natural gas, a lot of
a dingy Electrolux factory.
Yeah.
With a lot of megapacks around it. And the city of Memphis is all in on supporting this.
Yeah.
Which is obviously smart for them. But you have not had a real test of scaling laws for training, arguably since GPT-4. And this will be the first test. And if scaling laws for training hold, Grok 3 should be a significant advance in the state of the art. That is an immensely, from like a Bayesian way to look at the world, that is like an immensely important data point. But if that card doesn't work, and I think it is going to work, I think Grok 3 is going to be really good.
Wow. Okay. I can see now why you said we need to watch this. What a great explanation that he just gave, that this was something that everybody thought was impossible. Elon comes in. This is what he does.
Rethinks it from first principles and
found a solution and saved Nvidia. Like, we didn't even know this. And this is what we have in our hands here for Tesla and XAI. This brilliant mind that's now so far ahead of everyone else. Not only the speed of implementation, but this kind of stuff, like implementing something everybody can't do.
Yes. And the implications are deeper than that, based on, the conversations that we've also had, inspired by like Brian Wang's analysis of the speed at which they even brought it up. So a couple things to just sit with and marinate in for a second. Elon now is Nvidia's most important customer, and that actually is on 2 fronts. So, okay, not only did he pioneer this breakthrough with the networking solutions that allow them to make this bigger thing. It's incredibly insane that it works at 100,000 GPUs. The fact that he's talking about going to 1 million GPUs, we don't know for sure that he thinks that we can network 1 million GPUs together as one single giant supercomputer brain. If we can do that, that implies a level of progress that is insane. But then if you factor in the fact that he is going to be able to build that data center 5 times as fast as the nearest competitor, and he's going to get his GPUs before anyone else. So Jensen's going to ship him Blackwells before Microsoft, before Meta, before Amazon. Like Azure is not getting this. So no one else is going to have access to Blackwells before Elon does it. He's going to get the biggest shipment, and he's going to put them together and make one giant supercomputer out of them. And the reason that Jensen's going to say, yes, you can do that, is that it means that everyone else now has to chase XAI to try and replicate it. And so the fact that they can do it faster and they're going to get priority on deliveries just puts them, it gives them a moat that no one is going to be able to compete with. They're able to execute technically harder challenges than anyone else